Hello. In this teacher walkthrough, we're going to look at the different sections of the PythonSponge website and how you can use these in your classes. As you go to the website www.pythonsponge.com, the first section is our tutorial, and it's a good place to experiment and find out more and introduce the site to your students. Once the book is loaded, it will be client-based, which means that you don't have to worry about disruption to the site from internet connectivity. The library can be controlled on the right-hand side, meaning that teachers can direct students to move from one task to another task. And you'll see that the library of books exercises consists of some examples which can just be run and some tasks which have to be completed. The first exercise is just a simple hello world in order to debug, and that earns you your first tick. An example achieves a tick just by running it, although the student is welcome to make changes, and it's good to encourage them to do so before moving on. Exercises, however, require some interaction and completion by the student. The student might try to complete the brackets, and unfortunately that's still not going to work because we're missing the quotes around the string. The error messages are given at the bottom in the console, and once we've debugged it, we then get the correct message. If I leave it with an error for the moment and I try to submit, we see that we failed the test. On this occasion it failed to compile. Let's imagine that I now have running code, but it didn't produce the correct message. I still get the red cross, but now it actually guides me by showing the expected output and my actual output. Once I have achieved the correct goal, I can earn my tick. And the tick for the student is shown in their report page, which you could ask them to screenshot and send to the teacher as evidence of their work. Section 2 of our site allows students to have quick access to a browser-based coding editor, and this provides them with 10 different scratchpad areas, all of which will be saved into the local state of the browser every time that they run. So as long as I remember to click debug here or run, the difference being whether breakpoints are respected or not, run will be quicker. Once I run it, if I switch back or indeed close the browser and then come back another time on the same computer on the same browser, as long as local state is being saved, then there it is still, and it can be reset back to the blank up here. Alternatively, it can be downloaded as a Python file, or indeed a Python file on the local computer can be uploaded to continue editing, and downloading and uploading locally is probably the safest way of keeping the students' work. Within this scratch area, students can engage with some fairly sophisticated concepts for GCSE, like reading and writing files. These will just make the files within the local storage of the browser. These would be lost when the browser was closed down, but they're good for demonstrating the basic file input-output functionality. On this occasion it creates a file and then reads it. And we can do some fairly sophisticated things, such as using our built-in canvas context object in order to create some interactive games. Stub code could be provided to the students, and then they could be asked to develop the code or the game further, either as part of a class project or an extension programming club. To aid the editor use, we have other little tools that are available, like minimizing the guide, the dark mode, or indeed using fixed inputs. And fixed inputs might be particularly useful for competitions where there's a certain set of inputs that always want to be tested to see whether we produce the required output. And here, if fixed input is enabled, then rather than taking input from the console, when the input command is experienced, the input will be read from this fixed input pane. Under the help, we have a list of different shortcut commands, including Alt up and down arrows to rearrange lines of code, F9 to toggle breakpoints, F5 to start debugging, or usefully F11 when you're inside the editor in order to go full screen. Section 3 provides some drag and drop problems. Once the book is loaded, in a similar way to the main guide. Now the problems appear as drag and drop, and we drag from the left in order to construct a solution. If the solution is wrong, we can still debug it to see what the output is, or in fact we can try and submit it. This will give us an error. This functionality comes courtesy of the JavaScript Parsons IO library. Again, Parsons problems are arranged into books with a report, and when we get onto the teacher editing area, we'll see that teachers can also make these problems in the same way that they're going to be able to make coding exercises. Section 4 is where we store our fun challenges. These are a collection of more open-ended activities which might be suitable for coding clubs or students who want to extend themselves. In fact, most of these exercises are written by students from our coding club. The older prefects write problems for the younger students, and we'll be adding to this collection over time. Each problem has some starter code, some gaps, and some tasks with some extensions in order to develop the students further. These are not auto-marked, they just run independently by the students as they develop their projects. Again, if a student makes a mistake and incorrectly loses some of their work, we could go back, but if they've already saved it and lost it, they can always use the reset button to get back to the original code from the problem. Section 5 shows our turtle and graphical examples. Actually, these code extracts would run in any area of the site, but we use these to demonstrate some basic integration with GCSE style turtle commands, in which, currently supported, we have most processing turtle instruction commands which are directed towards a turtle object. This includes GCSE concepts like colours, colours of borders, colours of fills, and indeed moving the turtle, pen up, pen down. Along with this, we also have examples of directing commands directly to an HTML canvas object. Now, to support this in Python, we actually create a new standard context object to which you can direct messages in order to draw on the JavaScript canvas. In this little example provided here, we show a little game of directing a paddle to bounce the ball. We can see commands being sent to the standard context. We will have more functionality for these commands in due course, but generally basic commands for constructing rectangles, circles, lines, these are all supported. If we use the standard context.present command, this enables double buffering to reduce flicker on the canvas, and what it means is that the context will only update every time the present method is called. When you first call present, that enables the double buffering, and then every other call to present will update the context to show the new state of the game. We can also use the context to check keyboard presses, such as on this occasion to quit, or indeed to move the paddle left or right. When you run the game, it's worth noting that in order to generate that, you have to click into the canvas first so that these key presses become detected and activated. Again, these structures can provide simple interfaces to allow starter code to be given to students with a range of interesting and extensible challenges. So section 6 is kind of connected with section 7 in that students can drag and drop or browse to an existing zip folder which contains a structure of Python files, guide text and test cases, and this open format will then load into your coding editor. So actually our tutorial, our drag and drop problems, our fun challenges, they all are just this structure of coding start files, guide instructions and a JSON file which contains the test cases. And what we really see as exciting is the potential for teachers and educators to create these challenges and share them with each other so that we can all benefit. And how do we actually make then these books of challenges? Well, we can use our coding editor in this section, and I'm going to go straight in with the new code challenge, which is the simplest, and just show that I've now only got a book of one challenge. I can rename its book name to something suitable for students, and perhaps I only want to distribute a single solo challenge for the start of a lesson. Well, I've just got a single page called starter. I'm not going to add any more pages. I'm just going to have that one page, and I'm going to edit the instructions in the guide. This is written using any valid markdown, or you can use any online markdown editor. Give some instructions for students. Making sure that I save what I'm doing regularly. And you can make some changes to the starter code or completely rewrite the starter code. We could say, I also love. Let's do another save. And what about the test cases? Well, if it's just an example, it will only have a debug and run option. However, if we would like it to be a challenge, then just for the moment, I will remove the isExample from the JSON and leave some test cases. I've got two test cases on this occasion. Blue, need to change it now to I also love blue, and I also love red. Now notice also here this wildcard match at the start of the output, because the prompt up here will produce some output to the output stream. I want to ignore all of that as long as my code ends with I also love blue or I also love red for that corresponding input. So we'll do another save again, and it's time to preview it. Preview opens in a new window and it shows you the student experience. You can debug it, you can submit it. Let's try and get it wrong first of all, and then right. And that's great, working well. Can reset the code back to the original if we want, but this is just in a preview window, so when I close it down, I'm back on my original designer window, and this is all ready to go, ready to deploy. So my deployment choices, well, I can either export it as a zip, and that's a great idea anyway, just so you've got it there as a backup, make those zips available to students or keep them for other teachers in the department, or hopefully start to share them between educators, which is something we're looking to develop. But if you're looking for a real quick fix for distributing that challenge, then you can also export as URL. What this does, spins up a new preview window with your challenge, and if you actually copy the URL from the top address bar for this preview, that actually embeds all of the data for the challenge itself as query string data. It's zipped up, it's quite a long query string, could be 200 characters, could be more if you've included several challenges in your book. It's definitely better to export the zip as well, so you've got that there, but actually this URL will take the students straight to where they want to go, straight into this view, ready for them to begin your challenge. So that's the quick and easy URL distribution method as well. Going back to the teacher area, perhaps I got interrupted and I wanted to continue the local editing I was doing. Well, the last book, just the last book that I was editing, that will still be available on your browser on this machine, ready to continue the local edit wherever we'd got to, which in this case was that. Notice I'm back into edit mode and I've got the right to carry on editing. However, if you want to edit an existing zip, well, you can just browse to that zip that you've previously exported, which is why it's always a good idea to make a backup of your state of play at regular intervals, and you can carry on editing from that point. You can also make a new code book, which is a more extensive list of challenges that you can begin to edit, and you can see our different types of problem. For example, you are welcome to make Parsons problems. You just put the code here in the correct order, the order you want them to be, and then when you preview, you'll get a Parsons problem for dragging and dropping, including indentation. Now, how did it know it was a Parsons problem? Because its type is set to Parsons inside the challenge settings. And similarly, perhaps with our turtle, we've got a canvas, got a turtle. With the turtle, you'll notice Again, the type has been set to canvas because we need the canvas to be available so that the turtle can draw on the canvas. And so there are some other examples here, and of course you can add or delete your own pages, and this page explains to you how to do that. Once you've finished building your challenge book, you've exported it to a zip, how are you going to distribute it to students? Well, you might make it available to them via your local intranet, and then they can upload it directly. But you might also want to host it online. And one option is to host it somewhere like Google Drive. And in fact, then you can just create a link which points directly at your cloud-based zip folder by using this sort of format: www.pythonsponge.com/pages, and then we provide a zip path query string to whatever is your share URL, for instance on Google Drive or on GitHub Pages. And in that case, when the students follow that URL, then because of the query string, it will automatically load your zip book from your cloud storage location and open it, and the children will be off in their coding editors. You might need to URL escape your share URL using an online tool such as urlencoder.org. That would be using that tool first, so that the path that goes here inside your query string that you share with students, that might need to be URL escaped. So the teacher area then provides everything that you need in order to start building and sharing challenges, and we really look forward to adding some new functionality over the next few months so that we can start to share those challenges with each other as educators. We hope you enjoy exploring the site with students, and we really do welcome your feedback directly using the contacts on the site.